For the last two episodes, we've had a plan. Backprop computes the gradient descent steps against it. But that plain step, just subtract the gradient, turns out to be surprisingly clumsy. Today, we make it smart. This is the story of optimizers and how we went from basic descent to the algorithm that trains almost every model today, Adam. Here's the baseline we already know: stochastic gradient descent, or SGD. Take the gradient on a mini batch, multiply by the learning rate, subtract it from the weights. Simple, and it works. But it has two real weaknesses that show up the moment you train something serious. And every modern optimizer is a fix for one of them. Weakness 1: ravines. Imagine a lost surface that's steep across one direction but nearly flat along another, a long narrow valley. Plain SGD bounces back and forth across the steep walls, making tiny progress down the gentle slope toward the goal. It wastes most of its energy oscillating side to side instead of moving forward. It's slow exactly where you need it to be fast. The fix is borrowed from physics, momentum. Instead of stepping purely by the current gradient, we keep a running velocity, a memory of the directions we've been moving. Each step adds a little of the new gradient to that velocity, so consistent directions build up speed while the back and forth wobble cancels itself out. It's a heavy ball rolling downhill instead of a feather blown around by every gust. Watch the difference in that same ravine. Plain SGD zigzags across the walls. Momentum smooths the path. The sideways wobbles cancel. The downhill direction adds up, and it sails to the bottom far faster. A close cousin, nester of momentum, sharpens this further by peeking ahead before it steps. Momentum solves problem 1. Now for problem 2. Weakness 2: a single learning rate for every weight. But weights aren't equal. Some sit on steep parts of the loss and need small, careful steps. Others sit on nearly flat parts and need big ones just to move at all. Forcing them all to use the same step size is a compromise that's wrong for almost everyone. We want a learning rate that adapts per weight. The first idea was AdaGrad. Give each weight its own learning rate and shrink it based on how much that weight has been updated. Weights that have moved a lot slow down, quiet ones keep their pace. Clever, but it has a fatal flaw. It adds up every gradient ever seen, so the learning rates only ever shrink. Eventually they crawl toward zero and learning grinds to a halt. RMSProp fixes that with one change. Instead of summing all past gradients, it keeps a moving average. Recent gradients matter, ancient ones fade away. Now the per weight learning rates can shrink when needed, but also recover, so training never stalls. We now have two great ideas living separately: momentum for direction and RMSProp for per weight step size. And then someone simply combined them. That's Adam, adaptive moment estimation. It keeps a running velocity like momentum to smooth the direction, and it keeps a moving average of squared gradients like RMSProp to scale each weight step. Two memories working together, one for where to go, one for how far. That's the whole trick. Adam gets the best of both worlds. The momentum part powers through ravines and noise. The RMSProp part gives every weight its own sensible step size. It works well out of the box with very little tuning, which is exactly why it became the default optimizer for deep learning. When in doubt, people reach for Adam, often its variant AdamW. Put them on the same loss surface and the story is clear. Plain SGD scrambles, zigzagging its way down. Momentum cuts a smoother, faster line. And Adam drives almost straight for the minimum, adapting its stride the whole way. Same gradients, same goal, but how you use those gradients makes all the difference. One more layer sits on top of all of them: the learning rate schedule. Even Adam benefits from changing the base learning rate over time. A common pattern is warm up. Start tiny and ramp up so early unstable steps don't blow things up, then slowly decay. taking smaller and smaller steps as you settle into the minimum. Big strides early, fine adjustments late. So, which optimizer should you use? The honest answer is short. Reach for Adam or Adam W by default, it just works. For some vision models, well tuned SGD with momentum can generalize a touch better, but you'll rarely go wrong starting with Adam. The takeaway: the gradient tells you the direction, but the optimizer decides how to move, and a smart optimizer can be the difference between training in hours and not training at all. Next time, the other half of good training, stopping the model from just memorizing, that's overfitting and regularization. See you there.